Cabinet implementation. This implementation looks how the cabinet is in the industry. It is divided into sections, control and power. The power section is composed by a disconnector as the main protection for the system. A motor starter follows the direction of the electricity. Also, it communicates power and control section. Then the motor is also in power section. The control section has a thermomagnetic switch as protection, two buttons and two lights that indicate whether the system is on or off. The functionality of the implementation was the following. The disconnector was turned on, then the thermomagnetic switch too. With that, the whole system was energized. Then the start button turned on the motor and the stop button stopped. Table implementation. This implementation is an interpretation of the previous one, so the functionality is practically the same. The only variation is that in this section were used the two connections of voltage of the motor, low voltage and high voltage. These connections of the motor can be seen in the motor or in a manual too. In this implementation, to control the direction of the motor, the line 1 and 3 were inverted and the spins of the motor had inverted. VFD implementation. Here the motor speed is manipulated using a variable frequency drive. The characteristics of the motor were configured in the VFD using the adequate commands. Then there were two macros. Each one manipulates the motor with different elements. The first one using directly the VFD and the other using a potentiometer and a switch. The connection was the following. The disconnector was connected to the three-phase signal, and the output of the disconnector was connected to the VFD, but just two lines. Internally, the VFD, with the use of different electrical and electronic devices, generate a three-phase signal as an output, and these output were connected to the motor. In the macros 1, using the button of the VFD, the motor was turned on and using the arrows placed at the right of the screen. The up arrow increased the frequency and that way increased the speed. The down arrow did the opposite. It decreased the frequency and the speed. Those values were seen on the screen of the VFD. Macros 2 worked with the use of a potentiometer, which did the same as the arrows in macro 1, but in this case using it. The position of the potentiometer sent a value of frequency, and that value was turned into a speed. The direction of the spin indicates if the motor increase the speed or decrease. Rheostat. The rheostat was used to manipulate the speed of the rotor. The position of the rheostat indicates the quantity of voltage that the rotor receives. There was an initial value of voltage that it has to receive to start working. The thermomagnetic switch was connected to the line and the output of it was connected to the rheostat. The output of the rheostat was connected to the motor and at the same to indicator light. As the rheostat works similar to a potentiometer, according to the position, a different value of voltage was sent to the output that for this implementation was a rotating motor. There was an initial position in which the rheostat needed to be in order to start moving the rotor. Light bulbs. It was a thermomagnetic switch connected to the line. That line energized the light bulbs. They were 8 light bulbs plus one that the output. Each one of the light bulbs was connected with a relay and autocoupler. At the same time, the autocoupler was connected to a protoboard, which was connected to a DC voltage. Light bulbs. It was a thermomagnetic switch connected to the line. That line energized the light bulbs. They were 8 light bulbs plus 1 that was the output. Each of the 8 light bulbs was connected with a relay and autocoupler. At the same time, the autocoupler was connected to a protoboard which was connected to DC voltage. The light bulbs implementation divided the total voltage between all the light bulbs. The less light bulbs on. The more voltage they receive, in order to turn off the light bulbs, they were connected with a relay and autocoupler. The autocoupler was connected in a protoboard with DC voltage. When the autocoupler was connected to DC, it created a circuit that turned off the voltage.